Yeah, welcome everyone. I'm going to talk about flooding both from rainfall and from sea level rise. And I've been to Venice a few times, most often for sea level workshops, including the one where I took this photo in 2010 with San Marco flooded, which of course everyone who lives in Venice has experienced a zillion times. I start with a very old quote, and that is by Alexander von Humboldt. And he wrote in the year 1843 that humans are changing the climate, quote, by cutting down forests and by releasing large amounts of steam and gas at the centers of industry. So that is not a very new insight, and Humboldt knew the greenhouse effect, which was discovered more than 200 years ago by Joseph Fourier in 1824. So we've been talking about this for a long time, and I'm just very briefly taking some points in history. This is an important step in history when the Swedish Nobel laureate Svante Arrhenius was the first one to calculate what we now call the climate sensitivity, that is the amount of global warming you get from doubling the CO2 content in the atmosphere, and he arrived at 4 degrees. And this is still not outside the uncertainty range that we have. It's kind of at the high end of the uncertainty. Most likely the climate sensitivity is 3 degrees according to the modern science. And so we all know this, of course, how the carbon dioxide levels have increased in the atmosphere. It's now more than 50% higher than in the pre-industrial time. And the increase in the global mean temperature. CO2 we know exactly from the ice cores in Antarctica because we have samples of the air and it's a well-mixed gas, so it's everywhere the same in the atmosphere. With the global mean temperature, of course, you need hundreds of locations on the Earth to reconstruct the local temperature and then construct a global mean of that, and that's why there's an uncertainty range around the global average temperature, but that uncertainty is also small enough so that you can see that there is quite a strong, we're well outside the uncertainty range of temperatures for the last thousands of years. We're now at 1.3, actually now closer to 1.4 degrees warming above pre-industrial, which is a relevant comparison with the Paris Agreement goal of limiting warming to below 1.5 degrees. What else is there to say about this? Yes, a lot of people think, lay people, that because of this correlation that we see here between CO2 and temperature, we climate scientists think CO2 is the cause of the temperature rise. That's not the case. That warming was predicted before it was observed. So, as I said, Svante Arrhenius already in the 19th century, there was no indication that global temperature was actually increasing. That only became clear in the 1980s when it emerged out of the noise of natural variability. So this global warming was predicted before it was observed and is entirely correctly predicted. It's been developing for many decades now, also quantitatively exactly as it was predicted. If we look more closely at the instrumental record, starting from 1880 here, this is the NASA data, then we see this rise, we see natural variability around that, those interannual variations that come with El Nino events and things like that, but we see the very steady rise that has been going on certainly since the 1970s. And the first official government report on the then only predicted but not yet found global warming was the Rainfall report for the American President Lyndon B. Johnson, 1965. Then, 1988, Jim Hansen from NASA for the first time said in a Senate hearing in the United States that the long-predicted global warming is now here. We can now see it in the data. Global warming has begun, headline at the New York Times. This made headlines around the world. I was a PhD student in oceanography at the time, and I remember that, there was some discussions of some more conservative professor saying, maybe Jim Hansen was a little bit early, leaning out the window here, could still perhaps be within natural variability. Of course, nobody thinks that now anymore. It's, as I said, for decades, the warming is just proceeding exactly as we have long predicted it. 2 years later, the first report by the Intergovernmental Panel on Climate Change, IPCC, was published, which already in the very first sentence of that report says that it is certain that greenhouse gas emissions will lead to global warming. That has been well-established scientific consensus since 1990. And it led to the Rio Earth Summit, and where the Framework Convention on Climate Change was passed by all the countries, and that's why we now also, at the moment, we have these annual COPs, Conference of the Parties, and they are the parties to this Framework Convention on Climate Change, which was agreed upon at the Rio Earth Summit in 1992. And then there were all these annual COPs with intermediate step, the Kyoto Protocol, and then finally, 10 years ago in Paris, the Paris Agreement was agreed upon by practically all nations on Earth, with the goal to limit warming well below 2 degrees and pursue efforts to limit it to below 1.5 degrees. If you look at the background of the temperature curve, this hasn't been terribly successful so far. One has to say temperatures have continued to increase, and even the CO2 emissions have, until this year, continued to increase. So we haven't really done nearly enough. One reason for this is the constant lobby force of the fossil fuel industry. This is a well-known lobbyist, Steve Milloy, here posting on Twitter, concluding 8 years of cooling, CO2 warming is a hoax. And this is just a typical example of the climate denial that is anyone encounters every day, basically, if you go on social media. And the scary thing is not that there are lobbyists and special interest groups and stupid people distributing this kind of thing. The scary thing is, you can see on that at the bottom, this got 13.4 million views, and he posted very similar posts 50 times in that year. And as a climate scientist, you never get anything like that visibility in social media. I'm among the top 5 climate scientists in the world with the most Twitter followers, and I have never seen anything like several million views of anything I have posted. So the problem is the disinformation is really spreading faster than the serious scientific information. So maybe I should say, of course, he was referring to these 8 years from, do I have a pointer here? Yeah, this is an El Nino event, warming, and then, you get a few years where you don't see temperature increase because there's natural variations superimposed on that human-caused global warming trend. So it's a stupid argument. Now, we can also reconstruct the global temperature since the last ice age, 20,000 years ago, and you can see nicely the transition into the Holocene. Who knows what causes ice ages? Okay. 1? Oh, wow, okay. I learned that in school in geography in the 1970s. So this is really well-known stuff. This is the Milankovitch cycles of the Earth orbit, which were shown in the 1920s by Milutin Milankovitch. So this is also 100 years old knowledge. That's why we have regular ice age cycles. And so this is the last ice age, 20,000 years ago, and the transition into the Holocene. And now we had about 10,000 years stable Holocene climate, where at the beginning of the Holocene, Homo sapiens invented agriculture, started to settle down. So our whole civilization has evolved during the stable Holocene climate, which we have left behind now, as you can see on this diagram. And if we continue those different colored at the end, that is the different emission scenarios that depending on how much we emit, we will see more or less warming. According to the latest UN report ahead of that climate summit in Belém, with the current climate policies, we're up to about heading for about 2.8 degrees global warming, which would be a total disaster. An important aspect, of course, is the speed of the warming. The ice age cycles are quite slow. The shortest of these cycles has a period of 23,000 years. It's a precession of the Earth orbit. And so the warming out of the ice age into the Holocene was at a rate about 1 degree in 1,000 years. We have now done 1 degree in 100 years. And the last 10 years, we have done 0.4 degrees warming in 10 years. So warming is accelerating. And the climate scientists have commented on this a few years ago. One of my American colleagues said it's gobsmackingly bananas, the temperatures we are measuring now. And so somebody drew this nice cartoon about how climate scientists respond to the ever increasing temperatures. So sometimes I give talks with an audience where you can vote with your smartphone, and I can ask, what do you think, what percentage of global warming since the 19th century is human-caused? And majorities still vote for 60% or 80%, and few people know it's 100%, even though that's also well-established science that you can read in the IPCC reports. And as a matter of fact, we have probably caused slightly more than 100% of the observed warming, because the solar activity has counteracted, the decline of solar activity has counteracted a very small bit of the warming that we have caused by increasing greenhouse gases. Now, this warming was not only predicted by academic scientists in universities and research institutes, but also by researchers from the fossil fuel industry, for example, ExxonMobil. We did an analysis of their warming projections from their own Exxon scientists, which had come to light because of journalistic research. They were internal documents. And they made all these gray and black projections starting in the 1970s, again and again. And you can see that the Exxon scientists, first of all, got global warming pretty well exactly right. So the red line is observed, and all these gray ones are projections. Only the very first one overestimated the expected global warming by not accounting for the thermal inertia of the oceans. But the other ones are all pretty well spot on, and at no point did they think there was kind of less global warming than the academic scientists say, or even no global warming from their product. But they were telling the public a totally different story by paid advertorials in leading newspapers like the New York Times, Los Angeles Times, and so on. This is one of them. It looks like an editorial, but it's paid by Exxon. And it claims that human activities contribute just 3 or 4% to the CO2 emissions, and the rest, 96%, comes from nature. That is completely wrong. It's just mixing up a turnover, a zero-sum turnover of the natural carbon cycle with a net addition from using fossil fuels. And this argument is still around a lot. Our right-wing AfD party in Germany uses it in election campaigns and so on. So the kind of disinformation invented by the fossil fuel industry, it lives on in social media, in right-wing parties until this day. Now back to the real science. Now we come to the flooding issue. one of the consequences of warming is increase in rainfall extremes, and this is a study we published a few years ago based on weather station data showing that the number of record-breaking daily rainfall events is increasing. It's been outside the natural fluctuation range already since the 1990s, so statistically significant and increasing further and further, exactly as predicted by climate scientists. Example, daily rainfall events. This is a kind of flash flood in Germany that happened a few years ago. Yeah, if you were writing some disaster movie, it might look slightly exaggerated, but that is the reality. And then we had another one, for example, this German flood in Ahrtal, and colleagues from the ETH in Zurich, they are kind of top experts on extreme rainfall events, and they the year before that major flood, they published an analysis showing that also in Germany, the Netherlands, Austria, and Switzerland, extreme rainfall has increased. So it's just a fact that you see in the weather station data. And why does it increase? Because a basic law of physics, the Clausius-Clapeyron law, it's from 1834, and these physicists showed that the saturation vapor pressure of water vapor increases exponentially with temperature. And of course, rain falls when the air is saturated and then can't take up more water vapor, and then it falls out. And so that exponential increase shows how the atmosphere can hold more moisture the warmer it gets, and so more can rain down when the conditions are right. That's one aspect of it. The other aspect, by the way, is the same law is also a key reason why droughts are increasing, because if you don't have saturated air like on a rainy day, but you have a kind of more a dry day, then you have maybe 60% humidity, and then that vapor deficit that I show here, it's how much the atmosphere can still take on, increases, and that means that the soils and the vegetation dry out faster because they lose the moisture more quickly to the atmosphere when it's warmer. And so for more than 35 years, climate scientists have predicted that in a warming climate, extreme rainfall events will increase, and the kind of more normals, less rainfall, will tend to decrease. And that is exactly what is happening. And also you can read that in the IPCC report, which summarized it's extremely likely that on most land regions, heavy precipitation will become more frequent and more intense with additional global warming, and the projected increase in heavy precipitation extremes translate to an increase in the frequency and magnitude of pluvial floods, so high confidence statements. Pluvial floods, this is just from rainfall. And yeah, that just says this is now consensus, well-established science, and not under debate anymore. Now, the second aspect of flooding that I'll cover is sea level rise, and I have myself done quite a bit of work on sea level rise as an oceanographer, and another photo I took on Piazza San Marco in 2010 here. And so you see the sea level is rising. And you see also that since the 1980s or so, it's clear that the sea level rise is accelerating. It's rising faster and faster. We're now at a rate of over 4 millimeters per year, 4 centimeters per decade. That it's rising is again logical because, of course, ice melts faster when it's warmer, and so the continental ice, the mountain glaciers, etc., are melting faster the warmer it gets, and therefore sea level will rise the faster the warmer it gets. You can see we're now at a bit more than 20 centimeters since the year 1900. That doesn't sound very much, but it does cause major problems already during storm surges, and also because it's not rising equally everywhere on Earth. The trends differ regionally because the sea surface is not completely flat like in your bathtub, the water surface, but there are various reasons why there are regional differences in the rate of sea level rise. And so the scale here goes from -10 to +10 millimeters per year. And as I said, the global mean is about 4 millimeters per year now. So there are substantial variations in the rate of sea level rise. And for example, the US Atlantic coast is a well-known hotspot of sea level rise where it's been rising for decades faster than in global average, probably because the Atlantic overturning circulation is slowing down, which would lead to this kind of additional rise on the American coast. The causes, I already mentioned ice melting, so that's on the top right here, exchange of water stored on land, etc. So continental ice melting is one reason. Then the next one from the right is that water expands as it warms. Warmer water has a lower density. Another one is terrestrial water storage, like pumping groundwater for irrigation in agriculture adds water to the sea level in the end. But also the reservoirs that we build takes away sea level rise by storing water on land in big artificial reservoirs. And then there are these regional differences like ocean circulation changes and especially relative to land subsidence. That is a big problem in Venice, by the way, and had to partly due to the weight of all the buildings, that those sandbanks that they were built on actually kind of subsided somewhat, but also here on the industrial part of Venice, big amounts of groundwater pumping led to the land sinking until they stopped that when they realized that in Venice sea level is rising faster than in neighboring areas along the coast, that they stopped the groundwater pumping. So there are local differences in relative to land sea level. The map that I showed was just relative to a satellite, so not accounting for land rising or sinking. Scandinavia is still rising because of being liberated from the weight of the Ice Age ice. And so in Scandinavia, the sea level is sinking relative to the land because the land is rising faster than the sea is rising. So the causes, I mentioned the causes overall, but if you want to quantify it, the main ones is the thermal expansion of the ocean and the ice loss. They both are roundabout equal. The ice loss, we have the glaciers contributing most of it because they melt faster. Greenland 15%, Antarctica 8%, because Antarctica is very cold, it's on the South Pole. But the main lesson is it's about half ice melt and half thermal expansion of the ocean. Now, I showed you the end of the last ice age when the temperature actually increased by about 7 degrees Celsius into the Holocene. The sea level then rose 120 meters. And that should be a warning sign. We can actually reconstruct those past sea level changes by sediment drilling, for example, in salt marshes. Here I was involved in some field work with American colleagues in North Carolina some years ago, because these marshes, these sediments, they build up as sea level rises, and you can then drill into those sediments and basically reconstruct how fast the sea level and how much the sea level has changed over time. And that is one of those curves, the last 2,500 years of sea level, where you see a little bit of up and down, but then this very steep rise as a result of human-caused global warming. And as I mentioned earlier, the rate of sea level rise is also increasing, and this shows it for the last 2,000 years, where basically the sea level was stable, and by now we have reached about 4 millimeters per year. One indication that has long been used to show that sea level hasn't been rising for thousands of years as it is now, like 4 millimeters per year. 2,000 years ago in Roman times, then the sea level would have been 8 meters lower if that had been ongoing. The climate skeptics, of course, they always argue, yes, sea level has been rising since the last ice age. That's not true. It had already stabilized in the last 2,000 years and has only begun rising again recently because of the anthropogenic warming. And the big elephants in the room are the Greenland and Antarctic ice sheets. They hold enough, Greenland enough for 7 meters of global sea level rise, Antarctica enough ice for 58 meters of global sea level rise. And so coming to the future projections here, the ice melting is luckily slow, and so that means we don't get meters of sea level rise right away, but we will get in the long run. It's just very slowly starting. By 2150, the IPCC projections show a range centered around about 1 meter of sea level rise, which would already be quite catastrophic for a place like Venice. For example, you can, you can't close the Moser gates all the time because there are rivers coming into the back of the lagoon. You get flooded anyway if you close it off to the sea. So the only way to save Venice in the long run is build a ring dike all around it to divert the rivers from the back so they're not raising the level in the lagoon, but also protect against the sea, the open sea. I said that Greenland and Antarctica together, they can contribute to 65 meters of sea level rise. That's not going to happen. That would take thousands and thousands of years, but it just means we can't even afford to lose a few percent of the continental ice that we have on land now. This would be, with the Statue of Liberty, the 65 meters of rise. And what does it mean for places like this? The Maldives, this is Male, the main island of the Maldives, they're already building a new island that is 2 meters higher. You can only do that, of course, when you are in very shallow sea and you have a lot of suitable sand to pump up to build an artificial island. So that's not a solution for many places, certainly not for Florida, for example. Now, Indonesia, Jakarta, I was on a lecture tour for the German government a couple of years ago there. And this is Jakarta. This is a seawall where they try to protect themselves against rising seas. And on the left of it, this is remains of a mosque, which was in the middle of a suburb. That suburb is now already gone due to sea level rise. And they are also building a new capital for Indonesia because it's clear they can't save Jakarta in the long run. With that, I come to the end of my talk. My conclusions, first of all, we are in the middle of a climate crisis caused by greenhouse gas emissions. There is no scientific debate about this. It is leading to increasing pluvial and fluvial flooding, so rainfall and river floods, the warmer it gets because of that's Clausius-Clapeyron law, the atmosphere holding more water in warmer climates. And our emissions will cause sea levels to rise for thousands of years, and it will rise the faster the warmer it gets. That's it from me. The IPCC summarized that in its synthesis report a couple of years ago, saying there is a rapidly closing window of opportunity to secure a livable and sustainable future for all. And the choices and actions implemented in this decade will have impacts now and for thousands of years to come, because the CO2 lasts in the atmosphere for thousands of years. The sea level rise will take thousands of years. So our generation, our politicians now have a huge responsibility for a very long-term future of humanity on this planet. Thank you very much for listening, and feel free to follow me on social media. Thank you.